Two of the most important ideas that distinguish the quantum world from the classical one are non-locality and contextuality. Previously, physicists have theoretically shown that both of these phenomena cannot simultaneously exist in a quantum system, as they are both just different manifestations of a more fundamental concept, the assumption of realism. Now in a new paper, physicists have for the first time experimentally confirmed that these two defining features of quantum mechanics never appear together. In the everyday world that we observe, an object can only be affected by nearby objects, locality, and when we make a measurement, the outcome does not depend on other independent measurements being made at the same time, non-contextuality. In contrast, the quantum world is non-local, as demonstrated by quantum entanglement where two objects can influence each other even when separated by large distances. And in the quantum world, measurements are contextual, so quantum systems do not have predetermined values but instead their values depend on how measurements are made. To show that a quantum system is non-local or contextual, physicists have defined inequalities that assume a system is the opposite, local or non-contextual. Then they perform experiments that attempt to violate these inequalities to show that the system is not local or non-contextual. So far, these two types of inequalities have never been tested simultaneously. In the new study, the researchers have attempted to violate both inequalities at the same time, but have found that only one inequality can be violated at once. Their experiment uses entangled photons to generate photonic quadrate-qubit systems. A qubit is a superposition of two states, whereas a quadrate is a superposition of three states. By performing various measurements on these photons, the researchers could violate the inequalities separately, but not at the same time.